Good morning, students. We are studying NCERT Class 8 Math Part 1 and Chapter number 4 Quadrilaterals. Today is 15 August 2026, and what we have studied till now in this chapter about quadrilateral, a special type of quadrilateral, that is rectangle, square, and parallelogram. Uh, in the previous class, we have studied some properties of the parallelogram that we will have a quick revision, and then we will move ahead in the chapter. What we have seen about the parallelogram, that parallelogram is a quadrilateral, number one. Parallelogram is a quadrilateral which has opposite sides are parallel. What next point we have seen, that the internal angles, we have seen the relation between the internal angles. This is 1, this is 2, this is 3, this is 4, A, B, C, D. What we have seen, that the sum of the internal consecutive internal angles uh, or adjacent internal angle, adjacent is the right word, the sum of the adjacent angle in a quadrilateral is 180 degree. Means any adjacent angle you can take, means angle 1 plus angle 4 is equal to angle 1 plus angle 2 is equal to angle 2 plus angle 3 is equal to angle 3 plus angle 4. That is, sum is always 180 degree. Understood? That we have studied about the parallelogram. And what was the third point? Point number C, that opposite sides are equal. See, opposite sides are parallel is point number 1 which we have studied, and opposite sides are equal, that we have also studied that opposite sides are equal. Understood? And what more we have studied about the parallelogram, that if we join the, yes, in this point we have studied one more point. What is that? That adjacent angles, the sum of adjacent angle is 180 degree, and uh, opposite angles are equal. Understood? So we have written this point here. Okay, we can write here. Sum of opposite angle sum of opposite, sorry, this is not sum, actually opposite angles are equal in parallelogram. Understood? Opposite angles are equal. And what was our fourth point which I have already written, that opposite sides are equal. opposite sides are equal. Now we will study this is what we have studied in the yesterday's class, means previous class. Now we will move to the next topic. What is the next topic? Next topic is our reduction number 8, and reduction number 8 is point of intersection of the two diagonals of a parallelogram. This is our parallelogram, and we have to see the nature of the point of intersection. This is our point of intersection. This is A, B, C, D, and AC and BD are the diagonals. Now we will see what is the relation between the diagonals. Understood? Before that, one more thing we have discussed in the previous class, that in Venn diagram, if this is square, this is the set of square, then this is the set of rectangle, and all the rectangles are parallelogram. Understood? So all the rectangles are parallelogram. In this way we have seen that, means all the rectangles are parallelogram, but not all the parallelograms are rectangle. That we have seen. How we have seen that? We have seen that in a rectangle internal angles are 90 degree, but in case of parallelogram it is not necessary that internal angles are 90 degree. Though the sides are parallel, and opposite angles are equal. Understood? Opposite angles are equal, but they are not equal to 90 degree. That's why they are different from. That is why all parallelograms are not rectangle. Understood? This is also we have studied in previous class, and I was just trying for revision of previous class. Okay. Now we have to see the relation between AC and BD. We will take a triangle. What actually we try to establish, that what is this point of intersection, because this point is lies on DB and this point is lies on AC also. So what is the nature of this point? Understood? Now we take triangle AOD and BOC. In triangle AOD and triangle BOC, what we have seen, that if we say 1 and mark it as a 2, we say that angle 1 is equal to angle 2. Why? They are a vertically opposite angle. Understood? Now DA is equal to BC. DA is equal to BC. Why they are equal? Since we know that the diagram is parallelogram and opposite sides are equal. Understood? And if you say this angle as 3 and this angle as 4, then you will see that angle 3 is equal to angle 4. Why? Because we can write here DA is parallel to BC and AC is transversal, and these are the interior opposite angle. Understood? Angle 3 and 4 are the interior opposite angle, and interior opposite angle of in a parallel line are equal. Means this is a parallel line and this is transversal line. The interior opposite angle is what? This angle is 1, this angle is 2, they are equal. This angle is 3, this angle is 4, they are equal. So interior opposite angles are equal. So we have used the same property, and by this we conclude that both triangles are congruent triangle. Understood? Means triangle AOD congruent triangle BOC. Now these both triangles are equal by taking the corresponding sides of the triangle. We conclude that DO is equal to OB. Understood? And AC is equal to OC. We have taken the corresponding part of congruent triangle. Understood? We have taken the corresponding part of congruent triangle and we come to the conclusion that DO is equal to OB and AO is equal to OC, which means that O is the midpoint of AB and AC. What this conclusion give us the information that O is midpoint of AC and BD. Understood? O is the midpoint of AC and BD. That this is what we have concluded, and this says that diagonals of a parallelogram bisect each other. This is our final conclusion. Diagonals of parallelogram bisect each other. Understood? See, we have established the relation that AO equal to OC and DO is equal to OB. It doesn't mean that all the four parts are equal. Means we have not concluded, we have not come to the conclusion that AO is equal to that AC is equal to AB. This is not we have concluded. We have only concluded that O is the midpoint. Understood? And this is what that our deduction number 8, and that is that the nature of O is that O is dividing the diagonals equally. O is dividing the diagonals equally, or midpoint of the diagonals. This is our deduction 8. Now we will move to the next topic, that is deduction 9. We will see what is that. Now before moving to the deduction 9, we will move to the topic 4.4, that is quadrilaterals with equal side length. Quadrilaterals with equal side length, actually we have seen that is the special case of the square, that all the sides are equal. It means that the adjacent sides are equal. Now we will see the adjacent sides are equal, and what is that the special what type of that quadrilateral is. Understood? So our topic is 4.4 quadrilaterals with equal side lengths. Quadrilaterals with equal We'll study this topic, quadrilaterals with equal side length. Now they are telling us about the geometrical construction, and this geometrical construction you can do with the help of your compass and all what all the instruments you get in your geometry box. And I am just telling you the procedure. What they are saying that draw a line, draw a line segment, and draw an angle and measure this length. Say this length is 5 centimeter, 5 centimeter length. With the same 5 centimeter length, make an angle of which is not equal to 90 degree. Understood? Just draw an angle which is not equal to 90 degree, so it is less than 90 degree, and the length is same, means this is also 5 and this is also 5. Understood? Then draw parallel line of 5 length and join this like way. This is also 5. Now we will see what special type of quadrilateral it become when the adjacent sides are equal. Now in this construction we came to know that since we are saying that adjacent sides are equal, means all any adjacent side which we can take are equal. It means that, what does it mean? It means that uh, all the sides are equal. So this is a special type of parallelogram. Understood? This is a special type of parallelogram, means it is fulfilling all the properties of the parallelogram also, that opposite sides are equal and opposite sides are parallel. And if you prove that the nature of this angle and this angle, and you can easily prove that opposite angles are equal, since just because opposite sides are parallel. And you will also see that these angles and these angles are equal. Let me tell you, this will be a revision how we can say that opposite angles are equal. And see the, this AB and DC are parallel, so sum of internal angle is 180 degree, and BC and AD are parallel, sum of internal angles are 180 degree, and this angle is common. In this way we concluded that angle B is equal to angle D, and in the same way angle A equal to angle C. So this diagram is fulfilling all the properties of the parallelogram. But in parallelogram, what we have seen that there is generally the adjacent sides are not equal. Means if it is 4, it is 6. Means this is a special type of parallelogram, and this is a general type of parallelogram. So since this is a special type of parallelogram, so we have a separate name for this figure. What is this? So we have seen that this is a general type of parallelogram, and this is a specific type of parallelogram which is not a square. So we will give it has a very specific name that we will see. What is the name of this type of figure? This is called rhombus. What this figure is called? Rhombus. Understood? This is rhombus. So we will study about the rhombus now. And what is the special thing about the rhombus? That adjacent sides are equal, but opposite angles are also equal, but internal angles are not 90 degree, otherwise it will become a square. This is not a square, this is rhombus. Now we will study about this figure rhombus, and our next deduction is depend upon this figure. So what is our next deduction that we will see? This is about the angles in a rhombus. Understood? Our deduction number 9 is angles in rhombus. Okay. This is our figure, and let's name it A, B, C, D. Understood? Okay. Let's join this diagonal, and now we will see the angles in rhombus. We will see the nature of angles in rhombus. Now see, in triangle ADC and triangle ABC, in triangle ACD and triangle ACB, what we see that, see by the property of the rhombus, as we have just discussed, that all the adjacent sides are equal. Understood? So this side is equal to this side, and this side is equal to this side, and all the sides are equal. So in this way we see that, and this side is common, so both triangles are congruent. Understood? Both triangles are congruent, or we can write it directly here. This is not a difficult task to write here again. So triangle ACD is congruent triangle ACB, right? And what conclude that, if we name it 1, 2, 3, 4, understood? If we name it 1, 2, 3, 4, what we see that angle 1 is equal to angle 4. Angle 1 is equal to angle 4, since both sides are equal, and angle 2 is equal to angle 3, since these sides are equal. Understood? And also angle 1 plus angle 2 is equal to this complete sum, means angle 3 plus angle 4, since this is also parallelogram and opposite angles are equal. Angle 1 plus angle 2 is equal to angle 3 plus angle 4, and with these we conclude that, what we conclude that angle 1 is equal to angle 4. You can place it here, angle 4, right? And you can yes, with these conclusion we have concluded that angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4, right? This we have concluded that, and just let me give you how these angles are equal. Let me tell you. Now see, angle 1 is equal to angle 4, that we have proved that these are opposite angles. angle 2 is equal to angle 3 since these sides are equal. Now angle A is equal to angle C since these are the opposite angles of the parallelogram. So angle 1 plus angle 2, angle 1 plus angle 2 plus angle this one, angle D, we will see this is 180 degree. Understood? Angle 1 plus angle 2 plus angle D is equal to 180 degree, and we also see that angle, this is also angle 1 plus angle 2 plus angle B is 180 degree since these are also the alternate interior angles. So what we have concluded that, no, this is not working. Actually what I am trying to prove that, I am just trying to prove that angle 1 is equal to angle 2. Understood? What I am trying to prove that angle 1 is, it is very understood, there are n number of ways to prove that angle 1 is equal to angle 2. And okay, we have taken the triangle angle triangle ACD and triangle ACB. We have taken these two triangles, and when we take the corresponding parts, then we conclude that angle 1 is equal to angle 2 by CPCT. Understood? Because all the sides are equal of a rhombus, so angle we take the both triangles, and when we take the CPCT, corresponding part of congruent triangle, and in the same way we can prove that angle 4 is equal to angle 3, and the conclusion is that angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4. Understood? So all these angles are equal. This is what we have concluded. Now when angle 1 is equal to angle 2, what does it mean? It means that diagonal is bisecting the angle. This is our conclusion which we are trying to conclude, that angles in a rhombus means angles are, these are the angles, diagonal is the angle internal angle bisector, means diagonal is internal angle bisector. Understood? Means a diagonal in a rhombus is internal angle bisector. It has bisected these two lines. This is our conclusion. Angles in a rhombus, and in the same way when you join the another diagonal, so this angle B is bisected by this diagonal, means this angle is equal to this angle. This is the conclusion, and this is a deduction of deduction 9, that angles in a rhombus are, how angles in a rhombus are bisected by the diagonals. Now we will see the next deduction. What is the next deduction? Our next deduction is the our next deduction 10 is about the parallelogram, sorry, about the rhombus. If this is rhombus, this is rhombus we have drawn A, B, C, D. Now what we have to see, we have to see that what is the nature of this point of intersection O, as we have seen in the case of the parallelogram and in all the quadrilaterals. Now what is the nature of this O in this diagram? That we will see today. Now if we take the triangle AOB and DOC, triangle AOB and triangle DOC, understood? What we can see that this angle 1, this angle 2. Can we say that angle 1 is equal to angle 2? Of course. This diagonal is bisecting and opposite angles are equal, and this bisecting, or moreover these two lines are parallel, so these are the interior angles. In the same way, angle 3 is equal to angle 4. Understood? Angle 3, sorry, this is in this triangle. Angle 4 is equal to angle 3, and these are the opposite angles. Understood? These are the vertically opposite angle, you can say 5 or 6. 5. Angle 5 is equal to angle 6. So basically we have proved that these triangles are congruent triangles. These triangles are congruent triangles. Now by the corresponding part of the congruent triangle, we can say that AO is equal to OC and DO is equal to OB. It means that O is the midpoint of AB and AC, means diagonals are bisecting each other. Diagonals are bisecting each other. This is the nature of O. Now what we have seen in case of a rhombus, that diagonals are bisecting each other, point number 1, and diagonals are also bisecting the internal angles of the rhombus. Understood? So in this way we came to the conclusion what is the nature of the O, or what is the point of intersection of the diagonals of a rhombus. Understood? This is our deduction 10. Now we will see that what is the nature of the angle between the diagonals. What is the nature of the angle between the diagonals of a rhombus? That we will study in the next class. Understood? In the next class we will study what is the nature. Is it any special case that the diagonals are intersecting each other at a particular angle? That we will see in the next class. Till then, take care and enjoy 15 August. Happy Independence Day. Thank you very much.